Cheers, Trish.
Today, my name is Aaron. I'm coming at you live from Singapore.
Good morning, good afternoon, and good evening to
Chips for everybody.
Chips for everybody. Yes, that would be an FYI.
we have Oleg and Mark. How's it going? Welcome to the stream and thanks for joining us.
I'm in San Francisco Bay Area, a little less snow than you guys see up.
How's it going, Tommy?
Hey guys, how are you?
Speaker? Daniel? Daniel, how's it going?
Hi, good, thanks.
Is an Azure function is just an entry point to All right, everybody. Welcome. Good morning, good afternoon, and good evening, wherever you're joining us from. Thanks for joining us live on LinkedIn and YouTube and on our Solace Community forum. Welcome to our third edition of the Solace Community Lightning Talks, where we host our couple members from our Solace community to talk about topics they're interested in, whether the integrations with Solace and different tools or any particular tooling in the event-driven architecture domain. So today I would like to introduce you to this event, and we have 5 speakers today. On our Solace community, we have monthly events going on. We host it live on YouTube, LinkedIn, X, and our Solace community. So if you are interested to stay up to date with a bunch of our events, feel free to turn on the notifications on LinkedIn and YouTube, or that bell icon on YouTube, and you will get notified on any future events that we have. We do host monthly and regular events, including Aaron's office hours. So some of you might have seen Aaron's office hours. We host them as well on our different platforms. And for those interested to rewatch previous events, you could check out our playlist on YouTube, where we break down different events into different playlists. So that's it for today. A couple of housekeeping rules. Today is a live event, so this is extremely interactive. If you have any questions or comments, feel free to put it on the chat window as well, and we will see it. We'll stream it to our speakers and live on screen. So if you've used any of the technologies that the speakers are going to be talking about, or if you have any questions about them, feel free to comment as well. So today I'm joining you from Vancouver, Canada. So it's a Pacific time zone for me over here. It is 7 a.m. And just feel free to put on the chat window, again, whether you're on YouTube or LinkedIn, where are you joining us from? I usually like to ask this question because we do host this event live. We have a global event, and usually we have a lot of speakers and guests, viewers from different parts of the world. So without further ado, today I would like to kickstart our Solace Community Lightning Talks with our first speakers, Alice Gibbons. She is the head of customer success at Diagrid and works with a team of sales engineers. Alice will be talking about Dapr, the distributed application runtime framework. And after her talk, we'll bring her live and we'll be asking a bunch of questions. So without further ado, let's go ahead and kickstart this lightning talk with Alice.
Hi, everyone. My name is Alice Gibbons, and I'm head of customer success here at Diagrid, where our mission is to boost developer productivity by providing tools and APIs for building cloud-native apps. And today I'm going to talk a little bit about Dapr and Solace and how they work together with the PubSub Plus platform, really to help you build enterprise-grade, platform-agnostic, event-driven systems. So, the shift from monolithic applications and building them to on a single server to using things like Kubernetes and containers, packaging them up and orchestrating them has really like marked a giant shift in complexity in the software. And of course, this is at the infrastructure level, but then, when you are deploying cross-platform using different infrastructure backing resources, also at the developer level as well. So this has led to a huge number of developer concerns exploding, things like higher application expectations for end user consumer apps, cross-platform interoperability, really across clouds or on-prem, developers building in polyglot applications, really using whatever is best language and platform for their system, and then just an increased number of security concerns with that increased surface area. Of course, also you have an unreliable network just by definition, and then you also require a increased amount of observability across this distributed environment. And this was really the impetus and the motivation of why the Dapr project was built. So Dapr is a set of APIs for building secure and reliable microservices. It stands for the Distributed Application Runtime, and it came out of talking to a ton of enterprise developers who were worried about some of these application concerns. And we've actually found that it actually speeds up development time by up to 30% by providing APIs for things like communication, state, and workflow. So, how do I describe Dapr in kind of one sentence? Decouple. So, how do you decouple developers from infrastructure concerns through application level APIs? And this, what does this kind of look like in practice? Say if you have a runtime platform, maybe you're deploying on something like Kubernetes, maybe you're not. You have Dapr as that abstraction layer between, your applications, maybe they're running in containers with the infrastructure level, completely having that kind of, unified API surface. And that kind of holds true also through, development, staging, and production environments. Of course, you're going to want to use different application infrastructure with dev than you are in prod, and having Dapr within that layer allows you to get, move across those environments super seamlessly. So we reached a really exciting milestone in November where Dapr is now a CNCF graduated project. So it is entirely free and open source. It was donated to the CNCF in 2019 and has just recently hit this graduation milestone, meaning that it is a proven track record to be used in production by a ton of Fortune 500 users, and it also has a huge, vibrant community behind it, which is really exciting. So, taking a look of how this actually works in practice, you have your application written really in whatever language that you want, right? Using any language or runtime, you're reaching out to Dapr, which is typically hosted as a sidecar over HTTP or gRPC APIs. Now, today I'm going to talk a lot about the PubSub API, and this is how this integrates with the Solace PubSub Plus platform. But there's a number of other APIs you get out of the box when taking a dependency on Dapr. Things like stateful workflow for building, durable execution applications for long-running workflows. Things like service invocation for like a request reply pattern between two services if you want to have synchronous communication instead of event-driven. Now, this is typically hosted on Kubernetes in production, but can really be hosted across any cloud or edge infrastructure as well. The other concept I just wanted to touch on super quick was the concept of Dapr components. And this allows you as a developer to completely abstract your infrastructure from your application. So, if you are using the Dapr PubSub API, you can take advantage of AWS SQS, Azure Service Bus, any Solace PubSub Plus, any of these components just by changing a configuration file. So you have this YAML configuration that provides the connection details of your underlying infrastructure. And these components allow you to swap that out without actually changing any of your code. So, some of the other benefits of the Dapr PubSub API, as I mentioned, it integrates with a ton of different message brokers. So we have over 15 different components for PubSub. There is guaranteed at least once delivery with a number of other resiliency options that are actually built in to the PubSub API that can be overwritten to, your behavior that you want. There's 3 different kind of ways to subscribe to applications. So if you want to have like no endpoint on your subscribing applications open, you can actually use what's called streaming subscriptions in Dapr. There's a ton of other features, things like message TTL, dead letter topics, content-based message routing, things like that. And then of course, from a Solace perspective, it integrates with the PubSub Plus platform via AMQP and MQTT protocols. So what does this look like from a demo perspective? Say if you have two different applications, maybe a JavaScript kind of React publisher and then a Python subscriber. They're each going to have a Dapr sidecar based on the sidecar model here, right? And this is going to, as I said, abstract kind of the communication via the message broker. And then, you are going to reach out to the Dapr sidecar via your local host, whether again running on your local machine or in production on Kubernetes, something like that. And this URL is provided by Dapr. So this 3500 port is where the HTTP URLs or APIs are exposed. We're going to publish on a broker, a message broker in this case named broker, and then we're going to publish on a topic A in this case. On the subscribing side, Dapr takes care of the subscribing or the subscriptions for you using a competing consumer pattern out of the box. And it's actually will route all your messages through to all the different subscribers, in this case onto whatever really endpoint or whatever business logic you want to run. In this case, we have the A route being routed to. And I did mention there's a number of, built-in things that you kind of get by using the PubSub API. So, not only do you have that at least once delivery guaranteed, but there also is, other resiliency policies you can overwrite for things like outbound from your application or inbound resiliency coming into your subscribers. You also get you get MTLS out of the box with Dapr. And you get access control at the application level. So you can actually specify which applications you want to have access to that underlying infrastructure or limit this just based on, through the Dapr APIs. You also have an observability built in, so you get distributed tracing just out of the box using the Dapr API. And then you can also send this to really whatever background you want using the OpenTelemetry protocol or specification. And this is all kind of wired up through what's called a Dapr component or a PubSub component. And you can kind of see here, this is an example of, the PubSub Solace AMQP component. So I have, the connection details running on my local machine. I have a local Solace PubSub Plus broker, the standard edition, just deployed locally. And then I'm publishing, on this broker here, which is actually corresponding to the metadata name via that component file. So let's get into a demo and just pop over to see what this actually looks like. So you can see on my VS Code here on my left-hand side, I have a React application, which is kind of showing just a super simple app. It's using Axios. I'm not even using the Dapr SDK at all. I'm literally just using a regular HTTP client via Axios. And what I'm doing is I'm posting via that Dapr URL as I talked about. So again, localhost, Dapr port in this case 3500, and then I'm going to publish on that PubSub name, which again is broker, which is going to correspond to the component that I'm plugging in at runtime. I'm going to publish on the topic that I specify within the message. And that's pretty much it. It's a pretty simple application. And then on the subscriber side, really on the right, again, I have this Python application, not using the Dapr SDK. Again, I'm just using programmatic subscriptions. So I'm providing the implementation for this Dapr subscribe route, which is going to, specify the configuration for how I want my applications to be delivered to what methods within my business logic. So I have both, topic A as well as topic C, and then, the implementations of both of these guys. And then I also have that broker, message broker, which is going to correspond to a component. And so the last thing I kind of need to wire this all up is this component file, as I talked about. And again, what I've done is I have a Solace PubSub Plus broker deployed on my machine as a container, and I am pointing to that just within that URL. Now, this could, of course, be living wherever you want, right? This doesn't have to be on my local machine. This is just kind of easy for demo purposes. So if I wanted to spin this up, I'm going to use the Dapr CLI to kind of run this locally. I have to provide a couple arguments here, and this is going to run both my application alongside the Dapr sidecar. You can kind of see these purple logs are for the app, and then these kind of blue and white ones are for the Dapr sidecar. And the only thing that's important here, one of the only things, is that I'm loading what's called this, broker component. So again, this component file into the Dapr sidecar on this side, and then I want to also start that subscriber on the other side as well. So I want to start that Python subscriber, similar thing. I want to make sure that that broker is kind of being loaded. And you can kind of see here, subscribing to topic A and C looks really good. So far, so good. And based on that, I'm going to jump over to the UI, and this is kind of just my React, PubSub sample. And I'm going to say, hello, topic A. Oops. So I'm going to submit that guy, and then if I head over now to my VS Code, I can see that kind of come through for both, on the publisher side as well as on the subscriber side as well. So, super quick, super easy to kind of get that wired up between two like polyglot applications locally. And then I can also see if I'm taking a peek at the Solace portal, I can see that I have two of these AMQP clients as well. And one of them is, I have two outgoing flows, so two subscriptions there. And then I also have, on the other one, I have one incoming flow, so one kind of publisher on that side. Now, the last thing I'm just going to do super quick is if I want to swap out from using Solace to using something like a Redis, which I also have running on my local machine, that takes seconds. All I really do is comment out. I just swap the name of that component. I'm pointing to a different Redis container on my local machine. I'm going to rerun both of those applications, both the publisher as well as the subscriber. And then, I'm going to do exactly the same thing. So I'm going to head over to that React app. This time I'm going to try topic C. Let's go submit. And then if I hop back to my code, I can actually see again, I was able to publish using Redis on just without any code changes and kind of get that application flowing through from my publisher to my subscriber. And to prove to you that I'm actually using Redis, you can see if I look in the Dapr logs here that I actually have swapped out. So I'm loading that Redis component again at runtime, completely dynamic using Dapr. And that was pretty much it. I wanted to just show you a few resources. All the code that I have will be available online. I'll just put that in the chat. And then if you want to check out, Dapr.io, any of the quick starts or some of the stuff I did today, or head over to Diagrid.io to see we offer open source support behind Dapr, as well as a number of tooling for running Dapr in production.
All right, that was great, Alice. Thank you very much for this talk, and I will be bringing Alice onto the stage. Alice, how's it going? How are you?
I'm good. How are you?
I'm doing well. I'm doing well. Thank you very much for the presentation and the demo with Dapr. That was great. We do have a couple questions, people joining us as well from different parts of the world. So we'll just go ahead and jump straight into kind of some of the questions that you had about that we have for the presentation that you just showed. From my perspective, I do have a question about kind of how does like wildcard subscription works with different brokers, and that could also tap into a question that we got on LinkedIn from Giri, which is, can Dapr tap into specific features of brokers like a Solace broker or something, and how does Dapr interact with this kind of interactions?
Yeah, good question. So since Dapr is an abstraction, there's obviously a number of features that it provides kind of on top of the message broker itself. So things like content-based routing, things like message TTLs, like that is provided at the Dapr level across all the message brokers. But then there are component-specific implementations that would have, features for Solace. Let's say. So like I think Gary was asking, like within the Solace broker, I'm not sure if a feature example, but like then you could have within that component specification, you could say, hey, I want to specify this specific feature within Solace, and that it kind of breaks the abstraction in terms of like, it'll still be using the Solace feature behind the scenes, but that's just, again, specified within that component file for sure.
Okay, great. We do have another question from YouTube, from Aaron on YouTube about the payload formats. So does Dapr, what payloads does Dapr support? Is it standard JSON, Avro, or can it be any binary format?
Yeah, good question. So it can be pretty much any binary format. You have to set the content type header. One of the things that Dapr does, I don't think I mentioned it, but it's using Cloud Events 1.0 as the specification by default. So what you can do is you can put a number of different things within that Cloud Event. Cloud Events, of course, has a spec that is specific to it. It's an open source specification. And there is a data content type, I believe it's called. It's the attribute there. And once you set that to be like, application JSON, text plain, whatever, XML, then yeah, you can send whatever you want within there. You can also send events within Dapr though without cloud events. So you can integrate with, let's say, you know, quote unquote legacy systems by sending a what's called a raw payload. And that would just essentially be like a non-cloud event wrapped event. And then your subscriber would just kind of pick that up as whatever really you're sending. So it's Dapr's not going to like change that the payload within that case. Yeah.
Okay. Good to know. We do have another question, technically 2 questions from LinkedIn as well, from Emil on LinkedIn. So the first one is kind of like, what's the typical use case of Dapr, and does it work with observability? And if it does, how does it work, and where does OpenTelemetry fit in this? So let's go for the first part of the question.
Yeah, lots here. There's lots of use cases. This could be a 30-minute answer. No, I'm just kidding. So there's a ton of different like use cases here. I would say like one of the most popular ones we see is really like across cloud. It's a really, really popular one because of that abstraction. It plays super, super nicely like across cloud or across environments. So if you are deploying on-prem, or if you are deploying, in different cloud environments, you can just swap out that component like I did in the demo, and then not change any of that code in your application to still work, and that's great. Also, similarly, like if you're moving from your dev environment to staging to prod, again, you're not going to use that same infrastructure backing resource, right? So we actually see a lot of like platform teams super liking Dapr for this reason, because they can like give their developers these like gold standard components that they've kind of pre-created or they have configured themselves, and then from that point, the devs can configure their dev components however they want to, and then staging prod as you're moving higher up within your environments. That's where kind of these specified components come in. So I would say those are a couple use cases. Again, platform engineering as well as really cross clouds. That's like some of the space we play really nice in. And then in terms of the OpenTelemetry and observability, so Dapr totally does integrate with OTel. In terms of like by default, both the metrics and the logs you can just output directly to OpenTelemetry, and then there is like built-in tracing via distributed tracing like through the system, through like any Dapr enabled applications by default, just by configuring what's called a configuration file. And so once you have that set up, you can send those traces to really whatever observability backend you want, right? So we typically recommend deploying like an OpenTelemetry collector. This is very standard, I think. And then once you have an OpenTelemetry collector, you can like send that to whatever, Datadog, Azure Monitor, you name it. It plays really nice with OTel. And you actually just have to propagate some headers yourself. So it'll kind of create the trace headers for you if there's not one existing, or you just have to propagate that header if it has been like more than one hop between applications.
Yeah. Okay, Alice, I have a lot of questions, but we will have to go into our next speakers. A lot of people are liking this demo, short and sweet. Some people are talking about content-based routing. Gonna learn more about that. So overall, thank you very much, Alice, for joining. And again, anybody else who has any questions, feel free to put it on the chat window. Alice, I know you did show a couple of code blocks, code interactions in your demo. So for those who want to check it out, Alice has kindly hosted her source code on the GitHub link below. So, and if anybody has any questions, feel free to either put it on the LinkedIn comment, and you can follow Alice on LinkedIn as well, and see if you have any questions there.
I'll stick around in the chat as well. Yeah.
Thank you very much. I appreciate that, and have a great rest of the day.
Thanks so much for meeting. See you later.
Bye now. All right. So we just finished from Alice, and that was a great talk. We have a lot of people joining us from all around the world. First, we've got Mark from Orlando. Thank you, Mark, for joining. We got Giri from Bangalore. We've got Boris from Turkey, Istanbul. And we have people joining us from Algeria as well, Kaful. And then we've got people joining from London as well. Hi, Phil. Nice to see you. Thank you for joining. All right, for our next speaker, we've got Ozan Gunlap. Ozan is a principal software engineer at Red Hat. Ozan will be talking about the Quarkus project overall and how it interacts with Solace. And I will go ahead and kickstart his presentation, and then we'll have him on screen. For those who are joining us right now, please let me know in the chat window, where are you joining us from, what country, city, state you're joining us, and it'll be great to see a bunch of people as well commenting. If you have any questions or comments on the talk, please feel free to ask it in the chat window. And without further ado, we'll go ahead and start with Ozan.
Hi everyone, this is Ozan from Red Hat. I'm working at the Quarkus project, everything around messaging, and we are going to talk about Solace integration with Quarkus today. A quick introduction into Quarkus. Quarkus is a software stack to write Java applications, particularly modern applications like cloud native, microservices, serverless, or even AI-infused applications. It turns out the optimization that we do in Quarkus for applications is more general and applicable to monoliths, writing CLIs, applying different architectural styles like event-driven, CRUD, batches, or even like message processing, stream processing, integration, etc. In Quarkus, we are based on a couple of principles that we put forward, which are like frictionless development experience, cloud readiness and production readiness, build time principle, and reactive core. Today I'm going to talk about just the two of those. Let's give an introduction to the build time principle of Quarkus. So in traditional Java applications, a Java application is built by compiling the Java classes against a class path, then packaging it into a jar, which is usually a fat jar which contains the application code classes and the whole class path. Then we ship that fat jar into a runtime where we execute it. And the execution goes on like unzipping the jar, reading the configuration, scanning the class path for annotations, etc., and then building the configuration, initialization of the classes. And then at the end, we can run the application and then you do some useful things. In Quarkus, the build time principle shifts that to the left, meaning that we can scan the class path and the configuration at the build time, run some optimizations and configuration code at the build time, and then package the application and ship it, so that when you run the application, it just runs the useful stuff and runs a lot faster. So the benefits that we have with build time principle is that we have a fast startup time and less memory usage on the startup especially. This is for the JVM, but it is also useful for compiling into native binaries. We're using GraalVM, which is very interesting if you are doing serverless like Lambda functions. So the startup time is much less and the memory consumption as well. Secondly, the reactive core. So the Quarkus is based on the reactive core of Eclipse Vertex project, which means that I/O threads are responsible for making the interaction between the network and the application. So this restricted number of I/O threads means that we have less thread blocking, and we use the resources of the system more efficiently. That doesn't mean that you need to write reactive code, reactive paradigms. You can still continue using blocking code. It's just that you will benefit from the reactive core, the whole interaction with the network. An added benefit is that we can easily integrate with the Java 21 virtual threads. So you have this whole different paradigms that you can use in your application. So we don't have much time. Let's see some code. We are going to see a very simple application which has two microservices. One is the code producer, which has a UI, which gets code requests and sends them to a Solace topic called code requests. And the second microservice will receive those code requests, generate a random price for the code, and send them back to a topic, which will be consumed back from the application and sent to the UI as a service sent event. So let's jump to our IDE. The first thing I would like to do is to run Quarkus in dev mode, the producer application. So what the Quarkus dev mode is a continuous compilation which compiles the application and starts up the application. And because we are using the Solace client extension, it will also create a Solace broker for us and configure the application to use that broker. So that will take some time, like around 30 seconds. We also have a second extension that is the messaging connector. So you see the application has started, and we can see that going through the dev UI, which comes with the dev mode of Quarkus, you can see the different extensions that are installed, the Solace and the Solace messaging connector. You can run tests continuously during the development. You can see the configuration of the application and also the dev services. So let's see if we can access the Solace UI from here. This is mapped to this random port, and I can get login, and the application is configured. The Solace namespace is connected by creating the Q codes for the producer application. I can also see that the producer application comes with a UI. And let's see if we can run the processor application as well. In the second application, it will automatically discover that there's also already a dev service running, and it will get configured against that broker. So inside the first application, the producer, every Quarkus messaging extension uses some abstraction to integrate with a message broker, being it Solace, Kafka, RabbitMQ, etc., etc. You always use the same abstractions to produce or consume events. For producing, a simple way is to just use an emitter where you can inject by an annotation, and then use that by sending an event. You can also inject to a stream of messages, and then simply use it in your application by maybe redirecting that stream to a server-sent events. So in our processor application, what we have is a block of code, a method that is annotated with incoming and outgoing. That means that we are going to consume events from a channel called requests and send the processed events to a channel called codes, which are then configured against topics and queues into Solace broker. So each time we receive a code request, we can go ahead and say that I'm going to generate a code with a random price and send back to the codes channel. We can see that that's executing, and it will restart the application with the new code without me touching the application, the demo. We can maybe change the bound and rerun it. Again, the fact that I triggered the application an endpoint, it will just recompile the application in demo. What we can also do is introduce an error inside it. So if price is bigger than 50, let's throw yeah. In that case, there will be some, of course, code requests that will be failing. But in Quarkus messaging, what we have is you can configure some different failure strategies for your application. In that case, what we configured is to use an error topic. So if the processing fails for some reason, we capture that failure, and we send the message to an error topic. In here, you can see that in our Solace UI. If I create an error queue and create some subscription on it, we will have that figuring in here, so that the application or the system can consume those events from the dead letter queue. The Quarkus Solace extension is maintained by the Solace team. Please feel free to, and with an open source license. So feel free to contribute to the discussions in GitHub, and you can check out the slides and the code of this demo using the Quarkus.
All right. Thank you very much, Ozan, for this presentation. I will go ahead and bring you on to stage. Ozan, how are you?
Good. How are you?
I'm doing well. I'm doing well. Happy
Great to be here.
for joining us. Yeah.
Thank you.
Yeah. How are things?
Good.
Great. That was a great presentation. Thank you very much for this. We'll jump straight into the question. So one of the questions that I had in mind, or maybe like, when I first started to take a look at Quarkus, is when it comes to Spring Cloud Stream. And that actually runs parallel with a question that we got on YouTube from Flamebot Gaming. Hey, Ray. I usually use Spring Boot, but if I wanted to get started with Quarkus and understand the differences, where is best practices to try that? And we could also kind of as well touch base on what are the differences between Quarkus and Spring Boot or Spring Cloud Stream in general.
Okay. So Quarkus and Spring are two Java frameworks, that's for sure. They are different ones, and Quarkus has a couple of advantages that I run through in the demo. A great place to look at those and more is Quarkus.io. We have some great blog posts and keep them updated with novelties. I think that's the landing page where you can go ahead and discover everything different and awesome about Quarkus. Then what I talked also about is the Quarkus messaging, which is let's say a sub framework inside Quarkus that I contribute, and that indeed we can compare it to the Spring Cloud Stream. In that they are very much comparable again. I think the most different part with Quarkus is we do support different dispatching strategies. One thing that I couldn't show in the demo is we by default we do call the message consumings on like thread pool threads, but we do support virtual threads. We do support like event loop threads as well through Vertex. So you have different execution strategies that you can apply. As much as like observability and integration with micrometer, etc., or open telemetry, I think Cloud Stream as well, Spring Cloud Stream as well, should integrate with those. So it should be more or less the same experience. So we do have a great support for open telemetry on everything like tracing. And it's also integrated with the Solace connector as well. Of course, the health checks work. Like most of the basic and fundamental integrations with the underlying framework, being Quarkus, works out of the box. So in terms of the Spring Cloud Stream and Quarkus messaging, again, they're very much comparable. Some customization stuff can change a bit, and of course, Quarkus messaging is integrated in Quarkus, which comes all the benefits that I spoke about.
Right. Yeah, you did mention something about customization. That kind of as well brings us to the next question from Aaron on YouTube. kind of, you saw that there was some like you use JSONP API within Quarkus. Can we expose Solace specific functionality via the JSONP API, the Solace API? So similar to the question that we had in Dapr. How's that possible?
So in terms of usage simplicity, we do like automatically convert the type that we see on the application. So if you are consuming a custom type that is like mapped to a JSON, we already do that conversion out of the box. But if you want to access the JSON-SMP type that you are consuming, you can also already consume that. So the application will inject that message into your application. In terms of more Solace specific settings, you can call when sending events or a new message to the Solace, you can customize everything when you're sending. Other than that, I think with the Solace client, we do have some one thing we do support is authentication with OAuth. I know that Solace has a great support of that, and we do support that. In terms of like advanced features, but obviously like basic access to the messages, sending and consuming them are already supported. So I mentioned the error strategy in the demo. The normal error strategy of like dead letter queues with Solace also works out of the box. I think we do have a custom one for Quarkus because some version of Solace didn't have that functionality out of the box. So I'm not really sure of the specificity of that, but the usual like reject and accept with Solace does work as well.
Yeah, potentially it was when we introduced the NAC functionality as well.
Yes,
with Solace,
exactly.
Where we could NAC messages. Yeah. Okay. Ozan, thank you very much for this. I know we're tight on time, but if anybody wants to learn more information about this or wants to get kind of like contribute, where would they be able to do that?
So I had the QR codes. There's also the Solace Quarkus project in Solace Labs organization in GitHub. So that's the place where if people want to contribute to the connector, it's open source. Also, like do interact and come to the Quarkus.io to see how great Quarkus is. Again, Quarkus is an open source project as well. You can find it on GitHub. And we do a lot of extensions. There's a separate organization called Quarkuverse. Their community maintained extensions do reside. So you can check out all different possibilities as well.
Okay, Ozan, perfect. Thank you very much for this. I really appreciate you joining us, and have a good rest of the day. Take care.
Thank you. Bye-bye.
Bye-bye. All right, everyone. So thanks for staying on and watching this. And we have people joining us from Paris, Christian from London. Hello, Christian, joining us. We've got people from Austria, Stefan, and he will be joining us shortly as well. And then we've got Hari from the Netherlands. Again, anybody who's joining us, if you're joining us right now, please feel free to put in the chat window where you're joining us from. And if you have any comments or question, or if you've used any of these technologies before, please feel free to put it in the chat. Right now, we're ready to jump onto our third speaker of the day. And I'd like to introduce Leonard Philips. Leonard is an integration consultant for Emixa. And he works directly on Boomi related integrations. And today Leo will be talking about a Solace feature that is used and asked about by so many people, which is queue browsing, and in particular the tool that Leo built and helped build as well with queue browsing. So without further ado, we'll go ahead and start Leonardo's presentation, and then we will chat with Leo right after.
Thanks, Tamimi. Today I'm going to show you the Solace Chrome extension we've been working on. So this is a queue message viewer. So a bit about me. I'm a New Zealander living in the Netherlands. I'm an integration consultant at Emixa. We work with Boomi and Solace. A little bit about Emixa. So we do digital transformations. We have a few core products that we work with. SAP, Mendex, and Boomi. And Solace, we use Solace with Boomi, and because it complements Boomi quite well. Yeah, so this is what we want to talk about today, the Solace Queue Message Viewer. It's a browser extension that lets you view your messages, the contents of your messages directly in the Event Broker UI on the queues. So here's, I've listed some of the key features here. I will go over these in more detail during the demo. The listing of the key features is message payload viewing, metadata viewing, multiple connections, which I think will be quite important, connection encryption, and the import and exporting of connections feature as well. So the use cases. So why do we need this? We found that during debugging and troubleshooting, whenever there was an issue, usually for DevOps, we wanted to see the contents of our messages when they got onto the queue, because that allowed us to identify whether or not an error was caused from data-related problems, or if it was an actual technical issue that required a change. So that was quite handy. This extension is quite handy for that. System monitoring, being able to monitor larger or see large message payloads, or if a message has ended up in the wrong place, being able to inspect the user properties to figure out exactly why it has ended up there and what the values are. Development and testing. So this is actually probably the biggest use case for me personally. Sending and inspecting messages. Using Solace with Boomi, we're sending messages from one system to another. And during development, you want to know if your data is right, if you're getting the right fields. So this helps a lot. The Chrome extension helps a lot for that. And then finally, operational maintenance. So if you ever, for whatever reason, need to delete messages from a queue, you can inspect it beforehand and know with more confidence that this is the right message that you want to delete. Okay, so now we'll move on to the demo. So I'm running a local instance of Solace. I will quickly log in and show you my setup. So we have one message VPN here, just everything's a default out of the box. And in this message VPN, we have one queue. This is just a test queue that I've set up, and one queued message. Let me show quickly how to download this. So if I drag across here, so as mentioned, this is a Chrome extension, so we can just find our Solace Chrome extension directly in the Chrome web store, or we can grab it from the GitHub repository. So this is where it originally was, and then we have a few contributors. But so today I'll do the demo in Chrome, so I'll just add it to Chrome. Okay, cool. So now that it's been installed, we've got an options. We can click on the icon and open the options tab. So this is where we want to configure our connections. So we want to connect to our local instance, and this is this options page is how we set up the connection. So as mentioned, there's one of the key features of encryption, right? So we need to be able to secure our passwords and not have them just stored as strings, free text fields. And so one way we can do that is through encryption. So the Chrome extension requires a password, encryption key. and then that encryption key will be used to encrypt the connections. Okay, so to add a new connection, there's a big connection, add new connection or new connection button up here. I'm going to call this connection localhost, as it is a local instance of Solace. Everything is standard, so it's all the username and password is just admin. Our message VPN is default. The host name, this is just a helper field for to make it easier to enter in the message VPN URL and the WebSocket or web messaging URL. But because we are using a local instance, I'm going to override these values and put in the local host out of port 8080, and then your web messaging URL is the WebSocket that you're connecting to, and the WebSocket we're connecting to here is localhost 8008. I'm going to click on display my message payloads, and we're going to hit and click save. You'll see up the top here it says successfully connected and ready to view messages. So it actually, when you click save, it actually it attempts to connect to your message VPN. So now I'll switch back to the queued messages, and we'll go to the try me, and we'll add another message here. So this is a queue, and my queue is called test. What is it? Test queue. Yeah. Test queue. We've got the standard default payload. I'm going to publish to that queue. If I go back to my queues now, you can see we've got two messages here, and we've got a new button up in the corner, find messages. So now that I've entered my connection into the options in the Solace Chrome extension, we can click find message, and we will see our message that we've just added down here, as well as a few other properties like the message ID. We can specify these. We can specify the destination name and the destination type. This metadata is quite handy if you're using dead message queues, because if you're inspecting a dead message queue and you want to know, well, where did this message come from, this will be populated with the original queue name that the message has come from. We can copy the message to clipboard and paste it wherever we want. So that's the local host instance, but also the Solace Chrome extension also works for cloud. I'll import a sandbox environment, and so here we have now all of our details already defined. So before we inspect the payloads on the cloud instance, I'll turn on another feature down here, user properties, application message ID. Yeah, that's it. I think thanks for letting me share this. And if you want to, if anyone out there wants to commit to this or contribute to this project, feel free to become a contributor. We'd love to try and expand this in any way we can to make it more useful.
Sweet. Thank you very much, Leonard, for that. The Solace Q Browser Chrome extension is actually a pretty cool project that me personally have used before, and I was pretty excited to use it only because I've used different kind of Q browsers, and this one I like how easy it is to use. So I'm going to bring Leonard onto the stage. Leo, thank you very much for this presentation. How's it going?
Yeah, good.
Good. Where are you joining us from today, Leonard?
So I'm in the Netherlands today.
Netherlands. Okay, sweet. Thank you very much for this. I do have 2 questions from my end, and then we have some questions as well on the stream. The first question, at the beginning of your presentation, you mentioned about multiple connections. So you can have multiple connections in the Chrome extension. Why is that important? And what about why do people need to configure these different connections?
Yeah, so quite often when you're running a Solace, when you're running the event broker, you'll have production, a UAT, maybe in a dev environment. So we wanted to have a bit more functionality and take away some of the hassle of having to copy and paste in different environment login details each time we wanted to, check out dev or quickly jump to prod or UAT or whatever. And of course, like if you're a Solace partner and you have multiple clients, it can even be better because you can have multiple clients instances stored in there. So it's quite a good quality of life feature that we introduced. That saved a lot of time and a lot of frustration with the login details.
I would guess that. Okay, no, this is great. The second question from my end, I know you mentioned, like you showed this demo on Chrome. Can people using a different browser be able to use this Q browser extension?
So at the moment, it only published to the Chrome store. Where I'm at the moment trying to get it published to the Edge store. Microsoft are a bit tougher with what software they allowed on there. There's a few more questions. I've actually got rejected for the first time I submitted it because I didn't explain how to test it well enough. So, but Google, they just let you upload anything apparently. So hopefully it'll be on Edge soon. It's on Chrome at the moment, but it basically should work in any Chromium based browser.
Okay.
You can download it from GitHub, all the source files there, and just import it. And it should, in theory, work. But if it doesn't, you find a browser that doesn't work, let us know. Maybe on the raise a bug or something for it, and we can take a look and try. And get
some people are using it on Edge. Someone commented that they're able to use it on Edge too. So this is great. One last question for you, Leonard, as well. It came from Mark on LinkedIn. Does the message have to be of a certain type in order to see the payload or copy paste it, or does it work with different Solace message types? Do you have any particular thoughts about this?
Yeah, so I assume message types mean like if it's an XML or JSON or that kind of like the format basically. I think maybe that's how I'm interpreting that question. That from that point of view, it doesn't matter at all. It could be any format. But if it's coming from a topic or a queue, it also doesn't matter either. You can view all the messages you'd like, and copy and paste it. Without problems. But
sounds good. All right. Well, Leah, thank you very much. I know we're tight on time, but this is great. If anybody has any other questions, as you mentioned, we could go to the GitHub repo or on the Solace community, and we'll be posting some questions there. And lastly, like a quick note, we have the Solace Connect event next week in the Netherlands, so I'll give more information to you for that if you would like to attend it in person. But apart from that, this is awesome. Thank you very much for this talk, and as always, we appreciate your contribution to the Solace community, because the Q browser is a project on the Solace community GitHub organization as well. So your contribution is extremely appreciated as always.
Cool. Well, thanks for having me.
All right, Leo, take care. Bye now.
Bye.
All right, everyone. So this is great. We've got more people trickling in on LinkedIn as well. So regardless where you're joining us from, please let me know in the chat window. I would love to know which country, city, state you are joining us from. And again, as always, if you have any questions or comments, please ask it in the chat window or head on over to our Solace community and join us as well. So right now, next we have Stefan Fritz. He's a lead architect at Conapi in Austria. And Stefan will be talking about Message Manager. So without further ado, I'm going to go ahead and stream Stefan's talk.
Hello, my name is Stefan Fritz. I'm the CEO and technical lead of Conapi GmbH. I have more than 20 years of experience in the enterprise application integration and API management space in various roles. And after being on the road and working in consulting and project delivery and various roles, I established Conapi GmbH in 2019. We are a boutique system integrator providing enterprise application services and API management solutions. Our main offerings are managed services 24/7 for enterprise integration solutions. Our flagship product is the API box, which is a fully managed service for Gravity for small and medium business customers. And we also provide integration solutions and DevOps products. And today we're here to talk about one of our DevOps products, which is Message Manager. Message Manager is a multi-broker DevOps utility that allows you to interact with messaging systems, manipulate messages. It provides scripting capabilities, message management, so that means you can move messages between queues, destinations, topics. It is a cross-platform tool, and it comes with commercial support and maintenance, plus automatic updates. So let me show you what you can do with Message Manager. So this is Message Manager. Message Manager allows you to connect to a variety of messaging systems and messaging brokers. For example, AWS, ActiveMQ, Apache Kafka, or your Messenger, formerly known as Sonic, and Solace. It allows you to configure which libraries you want to use, and then you can activate the specific profile for the messaging platform you want to work with. There is a Solace-specific connectivity screen here. You can configure the connection settings here, define how you want to connect to your system, and then connect. Here at the top, you see the different tabs inside Message Manager. Each of them provides a specific functionality. So we have the queue browser, as the name might suggest. It allows you to browse queues, so you can see which queues are configured on your Solace system, how many messages are in the different queues. Topic subscriber, so you can see and consume messages from a topic. A message sender, which allows you to send messages to queues and topics. You can enter them directly, or you can send them from a file or from a folder. So you can point Message Manager to a folder and send all the messages from this specific folder to a specific destination, either directly, multiple times, or with a delay. And last but not least, there is also scripting support. Scripting support allows you to quickly generate messages, modify messages, dump messages, whatever you have in mind. So let's take a quick look at a few examples. So let me go back here to the message sender. I just enter here some message content. So you can just enter text or XML or whatever you want. It can also be JSON, of course, and it will be formatted here. You can pick a destination where you want to send this to. Here on the right-hand side, the destination type is outlined. I'll pick now simply test Q1 and send a message. So now I just sent one message. I could also change this here to 2 messages. Just send this and it sends 2 messages. Or here you can also define message properties, or you can point it, as mentioned before, to one file or a folder and send the content. I now go to my Q browser. I can see there are 3 messages. I can see the messages. I can individually click on them, take a look at the JMS headers, or if it is a different messaging system, the headers or metadata. I can click on the properties, look at the properties that are defined on this message, and of course, the message body. I can delete individual messages. I can drag and drop them to other queues, and I can save them to disk. There is also search functionality and filter functionality. I'll show you that in a minute. So I clear now the messages, means I delete all the messages from these queues for the next part of the demonstration. So I'll go now to my scripting module. You see here there are no messages. I have a few scenarios here. Here at the top we have script examples. You can define your script either in a Java expression language, like this, or you can use a Python script. A specific script in combination with a configuration here on the right-hand side is called a scenario. I have some pre-configured scenarios here now for this specific event. First, generate data. So this script here will use as the source a generator. It will generate 10 messages. The message source could also be the file system, or it could be a queue. But as said, here now it is just 10 messages from a generator. I'll generate some fake content, and the target is test Q1. I press the run button now. You can see here output from the script, and you can see here a summary how long it took to run this script. This was just a test run. Nothing has happened on my queue here because I'm in test mode. I switch now to live mode, run this again, and now I can see I have 10 messages in my queue. This specific script sets a message property, my property, with the value ABC. So let's go back to my Q browser, refresh here. I can click on this. I see the content that was generated, and I can see some of these messages. Oh, this one here, for example, has my property ABC. So with 10 messages, I can click through it, look at it, relatively easy, but let's assume you have 1,000 messages. You don't want to do that. So let me just enter ABC here. Message Manager highlights the messages here in the Q browser, and I know exactly which ones have the property set. Now here on the right-hand side, I can click Filter. Now I see only the messages that have these property defined. I can move them over here to test Q2, or I can delete them. I can also click again, and now I inverted the filter. I now only see the messages which do not match, which is also quite handy in certain DevOps operations. But let's go back to our scripting. So I still have my 10 messages here. I go now to scripting. I load my second scenario, which is filter and move. So this script will now do what I did in the UI. It will filter the messages, and those matching my property equals ABC will be processed and moved to test Q2. So I run this script now. It processed the messages. You see, it processed 10 messages, but it applied the action only to 4. So with this return value, result true or false, I can define inside my script whether to process that message, yes or no. In this case, I moved it to test Q2, but you could also do a reply or a delete or an export to the file system. And if I go here now and I refresh, you can see I have 6 messages still in test Q1 and 4 messages here inside test Q2. And these are the 4 messages containing my property here. And you see this message did have my property ABC, but the script has modified the message itself. That's also possible with the script.
All right, Stefan, thank you very much for this presentation, and I'll bring you on to stage right now. Stefan, welcome. Happy New Year. How's it going?
Thanks. Doing fine.
That's great. That's great. Thank you very much for this presentation. Stefan, where are you joining us from? Where are you based?
Joining from Austria today.
Okay, nice. So thanks for joining us and coming in live to present a message manager. I do have a couple questions for you, and we'll see if there's any questions as well on the live stream. So in particularly from the scripting perspective. So this is a pretty nifty feature and capability with Message Manager. Could you please let us know, like, what other things could you do with the scripting functionality as well in that perspective?
Yeah, so there is a variety of things you can do. So we have customers using it, for example, for testing, generating test data for their development machine. Others do day-to-day tasks. So, for example, I don't know, once a week you have issues with certain clients or systems sending invalid data, so you can fix that on the fly, so you can automate that. You can as a generate load on test systems. So, or take, let's say, copy data from one system, from one environment to the other by exporting it before.
Right.
So
there's a lot of like different capabilities you could do with the scripting. While we're in the topic of scripting, I know I see a lot of people as well are saying that they do enjoy the scripting feature. So Aaron on YouTube is asking about kind of from a performance perspective. How does the message manager performance, how is it impacted with deep queues? Let's say you have like a very deep queue. Have you seen any performance implications from this perspective?
So we are using it in day-to-day operations at our customers as well, and so far we didn't really see problems with hundreds of messages in the queues. I mean, if you have, I don't know, 5 million messages with each 1 megabyte, that might be a different story. Haven't tested that, to be honest, but so far we haven't had any complaints about the performance.
Okay. I know at the beginning of the presentation you showed different brokers. Is there like broker-to-broker interaction? Could there be like some sort of different like broker-to-broker interaction within Message Manager?
Right now, that is not foreseen. Potentially in the future. Right now, they are completely separate. But what you can do is for example, the scripting engine or the export. When you export the data to the disk from a message, you can reuse that in a different messaging provider. But this is also an easy way of moving data, let's say, from one messaging provider to the other one for testing, for migration scenarios, etc.
Again, the scripting capability comes in handy in this perspective. Yeah. Okay, perfect. And I know you kindly offered a free 1-year subscription to anyone who would want to comment, check out Message Manager on the post. So we have on the LinkedIn post, and Stefan will choose one person, and then we'll give them a free 1-year subscription, and it's valued at $99. So thanks for that, Stefan. Do you have any last thing you'd like to say about Message Manager or Conapi?
No, but it's just not one person. So everybody commenting,
everybody
who comments will get that license, not just one person. And
anybody that comments.
Whoever comments. But this special offer closes end of January, so be quick and you get a free license.
Okay, so anybody who would like to check out Message Manager, feel free to comment on this. Check out Message Manager and Stefan will provide you with a license valued at $99 for a year. And this is valid until the end of January. So if you're rewatching this recording, you are still eligible for this. Stefan, thank you very much for presenting and for being part of the Solace Community Lightning Talks. If you have any further questions, we will feel free to, we will definitely reach out, and people rewatching this recording will be adding some comments as well there. So thanks again, appreciate it, and Happy New Year.
Happy New Year.
All right, thank you very much, Stefan. Take care. All right, everyone. So we have one last talk for today. For those who are just joining us on YouTube and LinkedIn, please let us know where you're joining us from. You could also join us on our Solace community. I would love to know where everybody is joining us from. And without further ado, I am ready to present the last talk for today, Fahad Shah. Fahad is a developer advocate at RisingWave. He is based in Pakistan. And fun fact about Fahad, he is a Solace scholar. He contributed blogs to our Solace Scholar program. And for those of you who are not aware of the Solace Scholar program, you could check it out, solace.com, Solace Scholar program, and you could get more information about it. So without further ado, let's go ahead and present Fahad's presentation.
So hi, everyone. My name is Fahad, and I am a developer advocate at RisingWave. The topic of my talk is real-time data processing and analysis in capital markets using Solace PubSub platform in RisingWave. So let me introduce my talk. So today I will discuss how to build a robust and scalable pipeline for real-time data processing and analysis in capital markets. So I will explore an end-to-end solution using Solace PubSub Event Broker for event streaming and RisingWave for real-time analytics. So this talk is actually based on one of my joint blog with Himanshu Gupta from Solace, and everything like the full code as well as like all the details is a part of Himanshu GitHub repository. So you can visit the repository as well as like read the full blog on our website. Let me give you an overview. So our goal is to create a pipeline that ingests, analyzes, and processes real-time data streams from capital markets. So the key components will be a data generator. This simulates real-time events like market trades. And then we have a Solace PubSub. So it's a scalable enterprise-grade event broker for reliable messaging. And then RisingWave. RisingWave is a cloud-native streaming database that performs real-time analytics. So we demonstrate actionable insights from the real-time data in RisingWave using simple SQL, and then sends the results back to Solace for downstream consumption, and thus enable a closed feedback loop. So this is actually our pipeline architecture. So that consists of a data generator that produces real-time events such as trades, and a Solace PubSub. It ensures reliable distribution of events, and then RisingWave consumes all those records from Solace using MQTT connector. So we are using MQTT connector to connect Solace with RisingWave, and processes events with SQL-based analytics, just simple SQL. And then we send the process results back to Solace, again with MQTT connector for use by downstream trading systems or even real-time dashboards. So this pipeline designs ensures like seamless real-time data flow and data-driven decision-making in real time. Now let's discuss the data generator. So its purpose is to simulate a real-world scenario by generating events such as stock trades. So all the code behind this data generator is available on GitHub, and all the details is also part of our blog that also I mentioned. So its key features are to generate high-frequency structured data, and that supports multiple event types like trade, stock prices, and anomalies with configurable parameters like trade volume, price fluctuations, and it is designed by Himanshu. So the example of event format is we have like a symbol, like ask price, bid size, trade size, a 180 exchange, NASDAQ, currency, US, and trade price, date, time, etc. So that's the format of a message that is generated by the data generator, and it is sent to Solace. And the frequency is tunable of this data generator. For example, we have used 100 events per second. Now, let me give you an overview of Solace PubSub. So Solace acts as a backbone for event distribution in this scenario, and it supports various protocols such as MQTT, REST, WebSocket, MQP, and JMS. It provides enterprise-level reliability with high availability and disaster recovery, and it gives dynamic filtering based on its dynamic and hierarchical topics. So why Solace should be used? Because it offers proven scalability for high-frequency trading, ensuring low latency and high throughput and high scalability. Now what is RisingWave? So RisingWave is a SQL-based streaming database that is designed for event-driven applications, real-time ETL pipelines, continuous analytics services, and feature stores for building real-time AI systems. And you can extract insights from real-time event streams, CDC, and time series data. And it provides sub-second latency. And it unifies streaming and batch processing for live and historical data analysis. Now let's discuss setting up RisingWave for real-time analytics. So you can use RisingWave Cloud for simplicity and ease of use, or deploy it in your own runtime, either using Docker or Kubernetes. And after setting a RisingWave, now define a source table in RisingWave that ingests all the data from Solace topic, and then create a bunch of materialized views for streaming analytics. And finally, write SQL queries to calculate metrics like high-low trade prices, trade volume, and volume-weighted average price, VWAP. Now, this is an example, a query, and this query actually creates a materialized view for analysis based on exchanges in a specific time window, a time window of 1 minute from enriched market data, a data source, and then group by time and exchange. So it's a simple plain SQL. You can create a materialized view in RisingWave. Now we create a closed the feedback loop to Solace, because we want to send process data back to Solace to trigger alerts or downstream actions. So we have like a real-time dashboard or a third-party applications that can rely on this data. And to enable automated trading systems, update real-time dashboards. So example use case can be to detect price anomalies in RisingWave using SQL and notify downstream applications using Solace for immediate actions like buy-sell recommendations and real-time monitoring of stocks. So we use a capital market as a use case that involves a trading system that processes market data in real time. So the process includes live data. Live data is generated from stock exchanges, and Solace distributes this data in real time to RisingWave, and RisingWave calculates metrics like buy-sell signals and detect price anomalies, including high, low, and average trade prices, total trade volume, and price volatility, and VWAP. So, and then insights are sent back to Solace topics for immediate like actions as well as visualizations and for building real-time dashboards. So this enables high-frequency trading environments to make faster and more informed decisions as fast as possible. The key benefits for capital markets of this system or this pipeline is to detect anomalies and trends in real time, minimize latency for critical applications, and handle millions of events per second with very high scalability. And for a broader use case that involves unified batch and stream processing, seamless cloud-native integration, and cost-effective and scalable analytics. So what are the key takeaways? So first, Solace ensures a reliable, scalable event distribution. Second, RisingWave simplifies real-time analytics using simple plain SQL. And together, these two systems, RisingWave and Solace, enable actionable real-time insights from market data. The next steps can be exploring like advanced RisingWave features like window functions, multi-way joins, and user-defined functions, UDFs, and optimizing this pipeline for performance and scalability. and extending this architecture to other use cases like IoT or fintech. Thank you so much for joining today's session, and feel free to connect with us for further discussion on Slack, GitHub, and you may ask questions now. Thank you so much.
Perfect. Thank you very much, Fahd, for this, and I'll bring you on to screen shortly. This was a very interesting talk because, quite frankly, I have not been exposed to streaming databases as much details as now. So thanks for this. So I'll bring you on to screen to chat about so we'll see if Fahd is available for a quick Q&A. But for now, if anybody has any questions, feel free to ask in the comments. Fahd, I don't know if you can hear me. Thank you very much for the presentation. Okay, fantastic.
Thanks.
Yeah. Thank you very much. So Fahd, we have one particular question that came through on LinkedIn. It's about kind of the connection from Solace to RisingWave. So the question is about, is MQTT preferred over AMQP or JMS with Solace? So I know in the demo you mentioned things about MQTT. Is there any particular preference of MQTT or AMQP or any just JMS with Solace? Any thoughts about that?
Yeah, sure. So first of all, like Solace supports various protocols like MQTT, AMQP, JMS, etc. And RisingWave supports MQTT. So that's why like I use MQTT connector to bring the data from Solace into RisingWave.
Yeah.
And we are also like looking to build a full-fledged integration of Solace and RisingWave. So that is something we are looking into. So
yeah. Okay.
So it was out of necessity rather than like a preference between like AMQP or JMS.
Right. You did mention, so we have another comment as well on YouTube. You did mention things about the sliding windows. Is there any other types of analytical capabilities that are supported with RisingWave that you're aware of?
Yeah, sure. So RisingWave supports various window functions. Like we have like the window functions that are part of like traditional databases. Row number, etc. And we have like window functions that are particularly designed for our streaming databases or real-time workloads. So we have like a session window. We have a tumble. So these are like in a sliding window. So these are the time window functions that are that are specifically designed for real-time workloads, and they are part of RisingWave, and they are also a part of like other streaming systems like Materialized, Flink, etc.
Okay, great. And lastly, one last question from my end. I know you did mention there's kind of like a shared blog between you were interacting with Himanshu from Solace. If somebody wants to know more information about, good to see you. If somebody wants to get more information about RisingWave, where could we get some more information about that?
So first of all, like for the purpose to get more information about RisingWave, you can reach out to us on our Slack or to join our GitHub, as well as like reach out to us on LinkedIn, or me particularly on LinkedIn. So I'm actually like quite active on LinkedIn. So you can reach out to me if you want to learn anything about RisingWave or in particular in stream processing in general. So
okay,
feel free to reach out to me.
Good to know. I'll put the RisingWave.com and even like on LinkedIn and on the Solace community. If anybody has any questions, feel free to reach out there. We have one more question, Fahd. It's about kind of the support for notifications within RisingWave. So the question in particular is about, is it possible to connect these window functions with alert notifications? For example, if we get an aggregate over time across that it crosses a particular threshold, can we get a notification out? And is there a way to kind of have publish this notification as events into the broker for reuse down the road for other options?
Sure, yeah. For the purpose to create like notifications, you can use RisingWave user-defined functions. So for that purpose, you have to define some threshold that that if a value crosses that threshold, so that UDF will be processed, and that UDF can send a data to Solace or a third-party system for the purpose to notify the user, either through email or a Slack message, etc.
Right.
Yeah, I think it's possible. Yeah.
Perfect. Fahad, thank you very much for this. I know that there was as well like a blog about real-time data processing and analysis with Solace and RisingWave. So for those interested, you could check it out on RisingWave. Fahad, thank you very much for the presentation. We appreciate your contribution with the Solace community and the Solace Scholar program. And Happy New Year.
Thank you so much.
No worries. Take care.
My pleasure.
All right. All right, everybody, we have come towards the end of the Solace Community Lightning Talks. We've had 5 speakers today. That was a pretty exciting event. We had Alice Gibbons talking about Dapr. We had Ozan from Red Hat talking about Quarkus. We've had Leonard talking about the Chrome extension queue browser. Stefan from Conapi talking about Message Manager. And Fahad from RisingWave talking about the integration of RisingWave with Solace. Thank you to everyone who spoke, and for all the speakers, and for everyone who attended and asked questions and was interactive. We appreciate your participation. And as always, join us on the Solace community, solace.community. We have future events coming up from office hours and other events. We're constantly active on the Solace community. So go ahead to the solace.community and make an account if you don't have already, and you could feel free to interact with us. Without further ado, thank you everybody for this, and we will be wrapping it up. So thanks, and have a good rest of the day, and happy New Year's, everyone. Thank you.